Welcome, guys. This is your Captain Shreyas, and welcome to the last day, last session of your 5-day challenge. And if you have reached till this particular video, you should be proud of yourself, a big pat on your back, because not only have you revised 15 important chapters and their subtopics, these topics alone are good enough for you to clear JEE Mains and qualify for JEE Advanced. And that was the whole intent of these 5-day challenges, so that you get to know what those topics are, familiarize yourself with the concepts, revise them, solve some PYQs, and see how the teacher solves it. And that will push you towards solving more problems, more PYQs. In turn, that builds up that momentum. And I want you to continue that momentum, not just for these 5 days, but even beyond this. So it's time to finally wind it up. And this is your Captain Shreyas. Welcome aboard. Hi, King, HF, Tanusvi, Vishod. Welcome aboard, Laksh, Batman, all of you. And guys, I hope you guys are all prepared and excited about the session for tomorrow, which is at 6 o'clock, 5th of November. And if you have not yet liked this particular video, please do that right now. Many kids are waiting for it. And I'm pretty sure after the session, your mind will not only be blown, and some of you might know what to expect, but there are a lot of surprises, let me tell you that. Okay, so lots and lots of exciting things for the JEE 2026 serious aspirants. Okay, and if you were doubting yourself a little bit, trust me, this is that session which is going to change your mind, which will bring a good positivity in you and change your mood also. Okay, so let's begin with the class, and smash the like button of that session, mark your attendance, and also like this video also, because YouTube should understand, right, that yes, you are serious and what kind of videos it has to suggest you. All right, Pritija, if you are, I think you had commented about you're looking for a job or something in Vedantu. Please send me your resume on Telegram, or if you are on LinkedIn, please message me on LinkedIn, because that is the professional platform on which I connect for any kind of requirement, job posting, etc. So if you are serious, please reach out to me on LinkedIn with your resume portfolio. I'll definitely see what can be done for you. Okay, right. Hi Charita, good evening. Sir, chemistry PYQ book is good or not? Obviously, man, it is very good, Charita. It's, I mean, I have it right over here. I have to make a separate video for that also. The physics, chemistry, and the mathematics books, right? These are the books, basically the PYQ book. It has good collection of questions, all questions, all shifts, solutions, answer key. It is fun. Now this book is very fresh for me because this is chemistry. I'm not using it. I'm using the physics one. So I took the review from Diksha ma'am, and Diksha ma'am absolutely loved it, and she's entertaining herself with that particular chemistry book. So definitely go for it. It's a set of 3 books: physics, chemistry, and mathematics. Now, talking about the different subtopics which are frequently asked from gravitation. First is your universal law of gravitation, which talks about if you have 2 particles, they will always attract each other with a gravitational force of G m1 m2 by r square. These are the products of the masses. This is the inverse of the square of the distance between those 2 masses. G is your gravitational constant, whose value is around 6.67 into 10 to the power minus 11 SI units, which is Newton meter square per kg square. And yes, this force is always attractive in nature. It can never repel. It can also pass through other masses, and it also applies as a superposition principle. Okay, so you can say that if multiple masses are there, each mass will apply this gravitational pull, so that net force can be found by vector addition, which you have studied in 11th standard. Okay, yes, Vimala, this course is free. Which course? You mean the crash course? Obviously crash courses are paid, my dear, because a lot of hard work goes into it. Okay, you can see the research that my team and I have put in. It has taken me 2 months to prepare this particular crash course, to design the crash course, to make the subtopics, new set of questions, new pattern of questions, to train the teachers, to make sure the crash course is of top notch level. Every student attending that session will give 5 rating for every single session, that kind of crash course to be made. And if you're asking me, sir, if it is free, I think it is a joke only, right? Okay. Oh, shorts, romba massa, sir. Too good. Yeah, too good, right? I enjoyed making that short and roasting. Thank you so much. And if you have not seen the recent short video which I uploaded, please check it out. Anyways, two bodies are equal masses and certain distance. They attract each other with some force. If 1/3 of the mass is transferred to the other mass, then what will be the new force? So equal masses means m and m, and there is some distance between them and there is some force between them, and that force will be g mm, means m square divided by distance square. Now what you are doing, you are taking 1/3 of the mass and transferring it to the other one. Don't worry, Kamaleshwaran, tomorrow there is a lot of surprises for you. So if you are worried about the cost, I think that will be the last of your worry. So don't worry about it. Okay, that's what my advice will be. M by 3, if it is taken out, what is remaining is 2m by 3. And if you add it over here, m plus m by 3 will make it 4m by 3. So now there is going to be a new force between them, same distance. So G, mass 1, which is 2m by 3, multiplied by second mass, which is 4m by 3, divided by r square. So you will have gm square by r square as it is. 2 into 4 is 8, 3 3 is 9. So this will become that old force, because this is that old force, multiplied by 8 divided by 9. So 8f divided by 9 is option number C. Very good. Amazing. Okay. बिना रिवाइज करे बैठो क्या सेशन में? So this session is actually meant for revision. If you have not studied, then don't sit for this session. If you don't know anything about gravitation, then don't sit, because this is not like from zero level, from scratch level. This is like a revision session. If you have some idea about gravity, this will help you. Okay. Good evening, Azad. Pritija, I think I've answered your question. You have to message me on LinkedIn. All right. Okay. Pritija, then I would suggest message me on Telegram. That would be better. Okay. All right. Moving ahead to the next question on your screen. 4 identical particles are there on the vertices of a square. The gravitational force of the masses by the other mass is something. The length of the side of the square is how much? So 4 particles are given. Okay, and they're kept on the corners. If the gravitational force is already given to be this much, the length of the sides of that particular square is how much? Very, very interesting, guys. So what we should do in such a situation is first draw a square of some random side length. Let's say this is our square and the random side length is, let's say, A, or you can also call it X. It's completely up to you, which we have to find. And now let's place those masses. All are equal. Remember that. This is M, this is M, this is M, this is M. Now what will happen? There will be one force like this and another force like this. Each of these forces will be G M1 M2 divided by X square. G M1 M2 divided by X square. MM are same. And this mass is also going to pull me like this. So that is going to be G M1 M2 divided by this distance will be X root 2. So X root 2 whole square. Now these are the three forces. So in order to find the net force, please remember this is what is going to happen. First take the resultant of these two perpendicular forces, which will be G M square, which will be nothing but G M square by X square. Okay, this will come 2 times in perpendicular direction. So G M square divided by X square square whole root of 2, which is the resultant of the perpendicular forces. Resultant of the perpendicular forces. That resultant will be in the same direction as this force, because when you take these two forces, their resultant will be here. This force and this force will add together to give you the net force. So that has to be added to G M square by x root 2 whole square. That's it. So let's see what do we really get. Now I can see from everywhere what is going to happen is gm square by x square is going to be common. So it's going to just come out. This is 1 square plus 1 square whole thing under the root, plus over here we will have 1 by root 2 whole square. Let's see what do we really get now. So gm square by x square is common. 1 square plus 1 square is 2. So root of 2 plus 1 by 2 over here. So we can see that we have to somehow get 32. So maybe we can take LCM. So this will become gm square by what we can say 2 is over here. We will have 2 root 2 plus 1 and x square is over here. Now, if you compare both of them, it is very clearly seen that we have 32L square in the denominator and here we have 2x square in the denominator. Just compare, rest everything is the same thing. 2 root 2 plus 1 gm square everything. So essentially 2x square is 32L square. So x square is 16. So therefore x or 16L basically L square. 32 by 2 is 16. So x will be square root of 16 is 4. Square root of L square is L. So 4 times of L, that means option number 2. So this is the right answer. Right, everyone? Okay, perfecto. Azad, I'll definitely plan some time a visit to Coimbatore for sure. Okay. All right, Pritija, I'll have a look at it. No issues. Okay. Okay. Hi, Aki. Good evening. Nice to see all of you. Oh, PYQ sessions 2 will be planned in the days to come. Don't worry. Let's move now to the next question on your screen, and here it is. There are 3 identical particles A, B and C, mass 100 kg, straight line where AB is equal to BC is equal to 13. Force on a fourth particle of same mass at a distance of 13 meters on from the particle B on the perpendicular bisector of the line AC. The gravitational force on a fourth particle on the line AC, the value of the F will be how much approximately? Very interesting. Diagram is not given. Yeah, the PDF will be made available, man. Don't worry about it. Okay. The gravitational force from all these particles will be how much? So let's have a visualization first. See, this is, let's say, AB. Then we will have BC and then a perpendicular bisector like this. So there is one mass here, there is one mass here, there is one mass here. On a fourth particle P of the same mass, so that is over here. So this is our point P, this is A, this is B, and this is C. The distances are 13 meters each. So this is 13, this is 13, and even this is 13. Okay, everyone, till this point, absolutely clear? Perfecto. Okay, now what do we do next? What do we do next? The question is the force on the fourth particle P of the mass M is F, and we have to find the value of F. Okay, first of all, this P will be attracted by this particular mass, and this particular mass. Is that right? Now, if you see, this is 13, this is 13, this is 13. So this force will be along this line. This force obviously again along that same line over here like this. Okay, and how much will these two forces be? Each of them, by the way, first of all, figure out how much this distance will be. It will be 13 root 2. This will be also 13 root 2 by Pythagoras theorem. These are perpendicular. Not just them, even this is perpendicular. Keep in mind, because this is 45 degree, this is also 45 degree. Together it is 90 degree. Now each of these two individual forces P to C and P to A will be G m1 m2 divided by distance square, that means 13 root 2 square. Same thing for this guy also, G m square divided by 13 root 2 square, and this particular force will be nothing but G m1 m2 divided by just 13 square. Now it's something similar to the previous question. So in order to find that net force, first take the resultant of these two perpendicular forces, because these two perpendicular forces will give a resultant like this, that is in the same direction as this. So together that will give me the net force. So the resultant of gm square by 13 root 2 square and gm square by 13 root 2, okay, whole square, plus this force, which is nothing but just gm square by 13 square. So as you can see, gm square by 13 is 13 square, sorry, is common. Okay, this is also 13 root 2 square. Square is missing, my bad. Now what is there inside over here is 1 by root 2 square plus 1 by root 2 square. Okay, this whole thing under the root plus over here just 1 by 1. That's it. So this is going to be gm square by 13 square. 1 by root 2 square is 1 by 2. 1 by 2 plus 1 by 2 is 1. So this will be root of 1 plus 1. So is that right? So that is what I'm going to get. So gm square multiplied by 2 whole thing divided by 13 square, which is 169. Everybody fine till this particular point? Yeah. Okay. Perfecto. Yeah. This much is done. Yeah. This is 13 root 2. This is also 13 root 2. So yeah, this will be 1 by root 2 over here, 1 by root 2 over here. Yes. 1 by 2 plus 1 by 2 is 1. So root of 1 is 1 and this one is as it is. Something like that. So now mass is already given to be 100. Okay. So mass is basically given to be 100 kg. So we have 100 square into 2. So that is going to give me G multiplied by 1, 2, 3, 4, but into 2 times, so 2000 divided by 169. Approximately how much will it be? Approximately 169 is close to 200, very close to. I'm not saying it will be exact, it will be close to 200. So 200 and 200 will cancel. Approximately it will be nothing but 100 times of G. So 100 G is option number B. Is that right, everyone? Perfect. That is the correct answer. Yeah. The PDF will be available in the description box of this particular video after the session is over. All right. Just like the previous video, standard, or in the comment section, it will be pinned. Acceleration due to gravity on the surface is gravitational constant, universal constant capital G, mass of the planet upon the radius of that planet square. Sometimes mass might not be given, density will be given. So remember, mass by volume of the sphere will be the density. Using that, you can find the mass. Sometimes I'm saying. Next thing, if you are going inside the surface of the earth at a distance d from the surface, that is depth, then it is g, which is on the surface, into 1 minus d by radius of the planet. D is measured from the surface, keep that in mind. If you are talking about at a height h, then it is capital GM R plus h. H is measured from the surface of the planet. But if this height is very less, then you can use the approximate formula like 100, 200, 300 kilometers. But if the height is like 700 kilometers, 2000 kilometers, then you have to use the exact formula. So this formula looks very similar to this. The only difference is this is above, this is below. Second thing, you can see the number 2 here. That number 2 is not there. Okay. So for a very small height altitude, like the Mount Everest, barely 8 kilometers, or on the top of Burj Khalifa, hardly few meters. So in those cases, you can use the approximate formula at an altitude h, which is g1 minus 2h divided by r. The graph of this particular variation of acceleration due to gravity looks like a straight line till you reach the radius, and after that it goes like this. So this is how the acceleration due to gravity changes with the distance from the center of the planet. Okay, it rises till you reach the surface linearly. After that, it's a non-linear decrease. Okay, this is something which is very important. Let's start with some questions coming up on your screen. Assuming the Earth to be a sphere of uniform mass density, there is some body whose mass is 300 Newton on the surface. How much will it weigh do you think on a way at r by 4 depth under the surface of the earth? Interesting. First of all, if you go inside the earth, gravity will change, weight will change. So if you know how much is the gravity, your job is done. Okay, how much is the gravity? Let's find it out. Gravity at depth d is gravity on the surface, 1 minus depth divided by r. The depth is basically r by 4. This is the depth. Okay, so this will become g into 1 minus 1 by 4, which is 3 times g by 4. This also means the weight at depth d will be 3 by 4 times the weight on the surface. Now, how much is the weight on the surface? It is clearly mentioned, it is 300 Newton, right? So, how much is this going to come out to be, guys? Yeah, 300 divided by 4. Yep, and you have multiplied by 3. Come on, my dear students. How much is the answer? Yeah, 200, 100, 225. Very good. 225. Awesome. Awesome. 225 Newton. Very good. Very good. Very good. Amazing. Oh, amazing. Clear? Shall we go ahead? So this is 75 into 3. 75 into 3 is 225. So 225 Newton is the right answer. Moving on to the next question on your screen. A 90 kg body is placed at a distance of 2r distance from the surface of the earth experiences gravitational pull of exactly how much? Interesting. Observe it. It is placed at a distance of 2r. So this distance is quite large. So you cannot use approximate formula. And it is at a distance of 2r from the surface. So this 2r is basically height and it is large. So how much gravitational pull will be there? So let's do this. Acceleration due to gravity on the height h will be gm divided by g plus h, sorry, not g plus h, r plus h whole square. Now, instead of gm, I have an idea. We know small g is capital Gm by r square. That means capital Gm is small g r square. So why not replace the numerator with small g into r square, because I don't like substituting mass and that constant of gravitation. R plus height is how much? 2r. So 2r and then whole square. So this will become gr square divided by 1 plus 2 is 3, 3 square is 9, so 9r square. So this will become g divided by 9. So the gravitational acceleration is g by 9. Now let's talk about the force. The gravitational force at that place will be the mass multiplied by acceleration due to gravity at that height. Mass is 90 kilos. Acceleration due to gravity is g by 9. So this will become 10g. G is approximately 10. So this will be 100 newtons or approximately. Option number 4. Very good. If you guys got it. If you guys got it, awesome. Rosie, thank you for all the love from Tamil Nadu, man. Thank you so much, my dear students. Thank you so much. Yep, means a lot. Means a lot. Let's go to the next question on your screen. These topics are high frequency, high weightage. If you practice this, you will be very familiar with the JEE Mains paper. You will feel that you have already seen it. At what distance above and below the surface of Earth a body will have same weight? What this question actually means is, imagine this is your Earth and what you're doing, you are going some distance, let's say x on the top, and then you are going some distance x below. At this place and at this place, weight is same, means gravity is same. Now, what is the formula for gravity? At height h and at depth d. We'll just use that. At height h, it is gm divided by r plus h whole square. Gravity at depth d is small g into 1 minus d divided by r. I have an idea. Instead of small g, I will put it as gm divided by r square for simplification. This is gm. Instead of r plus h, it will be r plus x because height is x. And instead of depth, I will put x over here and put r over here. Gm will cancel. Gm will cancel, of course. So 1 divided by r plus x, the whole square. is equal to 1 by r square. Taking the LCM, this will be r minus x divided by r. Cross multiply. So you are going to get r cube is equal to r plus x whole square is r square plus 2rx plus x square whole thing into r minus x. As you can see, further going ahead, let's see what do we really get. So r cube is equal to, multiply this. So you are going to get r cube over here, r square into r. Then 2rx into r is 2r square into x, r into x square, r into x square. It's a big lengthy thing. Then minus xr square, x into r square, minus x into 2rx. So minus 2rx square and minus x cube, minus x cube. As you can see, r cube will cancel. Yeah, can you see that? R cube and r cube is cancelling out. Not just that, my dear warriors. Also, you will see, because nothing else is there, x square, this will become x square. So x will also cancel. You will be left with 0 is equal to 2r square plus rx minus r square minus 2rx minus x square. Just check this out. This is what you're going to get. Shift minus x square here. It will become plus x square. Then rx minus 2rx is minus rx. So on this side, it will become just rx. 2r square minus r square is just r square. On this side, it will become minus r square. This is equal to 0. This is what I'm going to get. It's a quadratic equation. Obviously, it has two roots. That solution will be the answer. So it's just purely mathematical after this point. Apart from algebra, nothing else is there. You just need to be careful with the terms. So x will be minus b, which is minus r, plus minus root of b square, which is r square, minus 4 into a, which is 1, into c, which is minus r square, whole thing divided by c, which is minus r square. Okay, perfect. So what do we get? Minus r plus or minus. This is going to be minus into minus, which is plus, by the way. This is minus r square like this. Okay, so r can be taken outside and we will have 4 plus 1, which is 5, okay, divided by minus r square. Okay, minus b, actually this will become plus, my bad. Okay, yeah. So see guys, what is it that you are, wait a minute, what did I just do over here? Why did I put plus r square? By 2a, na? So 2 into 1. Something wrong I did. Okay, 2 into 1. So which is nothing but 2. Okay, so this is just going to be r common. You will not take the negative root or else the answer will be negative. So root of 5 minus 1, the whole thing divided by 2. Negative is not possible. Negative root is basically not possible because then x will be negative. X has to be positive answer. So if you take plus root 5, this negative 1, r is common. So this should be the answer. So r root 5 minus 1 divided by 2, which is the fourth option. Yeah. Perfecto. Gravitation works in like wave function. Spidey, gravitational force is now proved to be in the form of a wave, but we do not study that in JEE. We just study it like a natural occurrence of a force like electric force or magnetic force. Okay, but yeah, gravitational changes in one place or in one heavenly body can affect other planets in the form of waves. Those are gravitational waves for which Nobel Prize was awarded recently. Chala Durani, yes, the Sigma crash will be launched and announced with the every detail. If you have been watching and following the channel till now, already you know more than half the features, but still there are surprises. There are still some tricks down my sleeve. I'm going to explain that to all of you tomorrow at 6 o'clock on the channel, 5th November. Okay. All right. Perfecto. Now, having said that, let's go to the next concepts of Kepler's laws. Yeah, very, very important. On this also many questions come. Laws of orbits, where it is said that the massive body around which smaller bodies will revolve is such that The path taken by the small body like a planet around the sun is always elliptical, with a massive body always at the focus. So something like this. This is that small mass which will be revolving around a massive body like the sun, and this will be at the focus. Actually, there are two focus, but any one focus, that massive object like the sun will be present. So this shape is always elliptical, the shape taken by the path of that particular planet or that small body is always elliptical. Next, law of areas, which says that how much area you sweep per unit time. Meaning, let's say this mass moves from this point to this point. So if you take this area, that is called as dA, and how much time it takes, let's say dt. So the area covered per unit time is constant, and this is angular momentum divided by 2 times the mass of that planet, by 2 times the mass of that planet. Angular momentum is conserved, so L is constant, 2 and mass are obviously constants. So the area swept per unit time is a constant, which also explains why that if area covered per unit time is same, when you reach here, because this distance is large and the area should be same, so it will hardly cover any distance. So when the planet is far, it will move slowly, but when you are close, then to cover that same area, it will move a large distance like this. So the speed is higher when you are closer to the sun. So this explains the accelerations or decelerations which the planet face in that revolutionary orbit. And this comes from angular momentum conservation. Lastly, law of periods, which says that the square of the time period of revolution is directly proportional to the cube of the semi-major axis, or basically the radius cube of that particular orbit. So in general, you can also say that square of the time period is nothing but proportional to the cube of the radius. And what you get over here is also very important. Actually, you get time in general as 2 pi root of r cube divided by gm. So this is the formula for time period that you get with regards to the radius. So, if you square both sides, time square is proportional to the cube of the radius or cube of the semi-major length of that particular ellipse. G is gravitational constant, m is the mass of the central planet. Keep that in mind. Okay. Having said that, let's look at some questions based on Kepler's laws. Very straightforward. This was asked in 2024. It says that there is a planet which takes 200 days to complete one revolution. If the distance of the planet from the sun is reduced to 1/4 of its original distance, then how much will it take to complete one revolution around that sun? That's the question. Time and distance, t square and r cube, basically Kepler's third law. We all know by Kepler's third law, t square is proportional to r cube. So t2 by t1 whole square is r2 by r1 whole cube. That's it. So the new time period is t2. The old time period is basically 200 days. Everything squared is equal to new distance is 1/4 of the original one. So r2 will be 1, r1 will be 4 times of it, whole cube. So having said that, what do we get over here? T2 square divided by 200 square will be 1 by 4 cube. 1 by 4 into 1 by 4 into 1 by 4. 4 4s are 16, 16 4s are 64. So this will be 64. So going on to the other side, T2 square will be 200 square divided by 64. So T2 will be square root of 200 square is 200. Square root of 64 is basically 8. So my dear warriors, how much will be T2 then? Check it out. Yes, 25 days. Very good. 25 days, which is the first option. Amazing. Yeah. Abhishek, will you teach full chapter? Abhishek, we are doing high weighted subtopics only. Like I said, even in my video today, this is a very important video. Please watch it. All these kind of doubts you will never get. High weightage topics for 99 percentile. Why this is very important? and why you should not trust any other high weightage video. You will understand after watching this video. I will not tell anything. You listen to it. It's barely 11 minutes. After this session is over, watch it. You yourself will understand, and look at the comments. It's insane. Yes, the sheet link, everything, I'll give it to you. Yeah, don't worry. Yeah, it's going to be launched tomorrow. Yeah, please check it out. It's very, very important. It's completely up to you, Darshan. Some students find that I am very fast, so they will watch after the session at 0.5x speed. Some students are comfortable, they will watch it as it is live, because you don't want newer backlogs. But some students find, sir, I can hear very fast, I want to save time. Yeah, you can watch it after the session is over at 2x speed also. It's perfectly fine. Anything is okay, as long as you watch it, as long as you understand, as long as you apply these concepts. Next one on your screen. Two planets A and B have mass m1 and m2, move around the sun in a circular orbit r1 and r2. Angular momentum of A is L and that of B is 3L. The ratio of time periods is... Interesting question this is. Not the usual one, and that is how JEE 2024 put a bouncer over there. First of all, masses are given, angular momentum is involved, ratio of time periods is also asked. So a lot of people thought this is Kepler's third law. But then in Kepler's third law, angular momentum is not there, mass is also not involved. So how do you solve it using third law? So better now we go to second law, which says that the area which you cover per unit time is nothing but angular momentum by 2 times the mass of that particular planet. Now this area, if it is a circular orbit, it is nothing but my circle's area, and this is the period of time of revolution. So one complete area is covered in one time period of revolution. So that's it. Circle's area is nothing but pi r square. Time period of revolution is basically t. Angular momentum is L, 2 times of mass. And the question is, find the ratio of the time periods. So time period will be pi, or rather 2 pi, 2 multiplied by pi into m into r square, whole thing divided by L. So this is what time period formula is coming out to be in terms of the given terms. So if I want TA divided by TB, 2 pi is a constant, so it will be MA, mass of A upon mass of B, into radius of A upon radius of B whole square. And lastly, angular momentum of B divided by angular momentum of A. Just taking the ratio. Starting off with the mass, two planets having masses m1 and m2. Okay, so MA is m1, MB is m2. Circular orbits of radius r1 and r2. So this will be r1, this will be r2, and this will be whole square. LB is 3, LA is 1, so 3L and 1L. So that's it. So the answer will be nothing but over here, yeah, the ratio. So this will be nothing but 3 times M1 by M2, 3 times M1 by M2 into R1 by R2 whole square. But as you can see, none of the options are matching. So what do we do now? What do we do now? Yeah, something else is needed to solve the question, because mass is there or radius is there. Okay, so something more is needed to solve the question. So what we do is, observe, this much is not enough. So I have an idea. We now use Kepler's third law, which says that a time period square, so TA divided by TB whole square, is proportional to the cube of the radius. So it will be R1 by R2 whole cube. So therefore TA divided by TB will be R1 by R2 whole raised to 3 by 2. Or rather, we can also put R1 by R2 is TA by TB whole thing raised to 2 divided by 3. Use this over here. That will help me with the solution to the problem. So let's see what do we really get. So now my ratio of time periods TA by TB will be Check this out carefully now. It was 3m1 by m2. Okay, so put 3m1 divided by m2 as it is. Okay, I want answers in terms of m1 and m2. So what is this R1 by R2? What is this R1 by R2? This R1 by R2 is nothing but TA divided by TB, whole thing raised to 2 by 3. But remember, this R1 by R2 was raised to the power 2. So this was raised to the power 2. So this will become 3 times M1 by M2. So this will become into TA by TB, whole thing raised to 4 by 3. Bring this over here. Bring this on the other side. So it's a crazy problem. It looks simple at beginning, but then when you involve yourself, it becomes very calculated. That is what I wanted to show you. Anyways, so going back over here, so this will become TA by TB. On this side, it will again become TA by TB, but whole raised to minus 4 by 3. Or you can do one more thing. You can do one more thing. You can bring TA by TB on this side and bring this M1 and M2 on the other side. So it will look something like this. M2 divided by 3 times of M1 will be TA by TB, whole thing raised to 4 by 3. This, when it comes on this side, it will become TA by TB, whole raised to minus 1. Is that right? So this will become TA by TB, whole raised to 4 by 3 minus 1 is basically 1 by 3. So whatever M2 by 3 M1 I have got, now cube it. So this will become 1 by 27 into M2 by M1 whole cube is TA divided by TB. That is exactly what we wanted. So 1 by 27 is there. M2 by 1 whole cube is there. So that is option number 3. So this question is actually a very good level question. It will be considered in the difficult category because many students will find, trapped once they use either second law or the third law. If you use third law, you are like, okay, I'm just getting this, but time period ratio is not in terms of radius. What do I do? So you will get stuck over there. Are you getting it? Everyone with me on this? Perfecto. Yeah. So TA by TB is not R2 by R1, nor is it R1 by R2 whole cube. These both options are wrong. So it will be one of this. So we had to use this in my second Kepler's law. That too, so much of manipulation is there. Trust me, try to solve this question on your own. I'm guaranteeing you, you will get stuck somewhere or the other. Okay, you will get stuck. So there is one question for homework. So please try to solve it. Okay, satellite orbiting the Earth is 9 times closer to the Earth than the Moon. What is the time period of rotation? So use third law. I'm pretty sure you can solve this 2025 PYQ. All the options are given. Solution and the correct answer is given on the next slide. How will you be able to see it? You can download this PDF after the session is over. The link for the PDF will be there in the description box or even in the comment section. It will be pinned. Okay, just give it one day. It will be there. Let's go to the motion of satellites formulas. If you take a satellite, it revolves around circular orbits and it uses the gravitational pull as the centripetal force to provide centripetal acceleration. So gravitational pull is Gm by r square is equal to mv square by r, which is centripetal force. From that you get velocity, which is root gm by r. Please note this small r which you are seeing over here is actually radius of the planet plus the altitude from the surface. Time period, just like Kepler's law would expect it to be, time period is 2 pi root of r cube by gm. If you square both sides, square of the time period is proportional to the cube of the radius, exactly following the Kepler's law. This formula you should know. Kinetic energy is half mv square, potential energy is minus gmm by r, total energy is negative gmm by 2r. Kindly note that the kinetic energy is actually negative of the total energy and the potential energy is 2 times of the total energy, just like you would see it in atomic structure. Okay, same thing. Okay, total energy is negative gmm by 2r. The negative energy signifies it is bounded to the pull. If it was positive or zero, it would be unbounded. It will not circulate around the planet. The satellite will be free to move then, which is what you don't want. Okay, let's have a look at it. A question on your screen. A satellite is launched into a circular orbit and radius r around the Earth. A second satellite, 1.03 hour time period, is larger than the first by approximately how much? Okay, time radius. Time period of a satellite, I just told you, is 2 pi under root r cube divided by gm. So the time period is larger by how much? So first of all, I will convert this like this. 2 pi under root of gm is a constant. This will become r raised to 3 by 2. So we all know by errors, the relative error in the time, this is a constant, so it does not matter, is relative error in the radius into the power, which is 3 divided by 2. Now time to substitute. So how much is the time period different by? So the percentage difference in the time period is 3 by 2. Difference in the radius, which is 1.03 r minus r divided by original radius. But since we are talking about percentages, we have to multiply it by 100. So how much will this be? 3 by 2. 1.03 minus 1 is 0.03. So this will be 0.03. And this whole thing multiplied by 100. Okay. This 100 into 0.03 is 3. 3 3s are 9. So this will become 9 by 2%, which is 4.5%. This was actually mixed with the chapter of errors, units, dimension. So if you did not know how this happened, you have to go back to units, dimension, errors. So whenever there are powers, the relative errors need to be considered. The constants are ignored. It does not matter. Okay. And the relative error in the final quantity is the power into relative error of each quantity being added. If there are more quantities, their powers relative error, their power relative error will come. Remember, even if this was minus, still modulus value, positive value will only come. Okay, so never take the negative value. Yeah. Thank you so much, Abdullah. Means a lot. Hi, Venkateem. Welcome aboard. JEE 2027 students should not ideally watch it unless you have completed your syllabus. There is also one common kind of question like, there is a satellite at an altitude, let's say, of 2r and is shifted let's say shifted to 4r, and the question is find the change in total energy and change in kinetic energy. So these kind of questions are also common. Let me show how to solve this. So in these type, first figure out what is initial energy, final energy, and then take the difference. Immediately you'll get the answer. So my initial energy will be minus g, mass of the planet, mass of the satellite, by 2 times the radius. The radius will be r plus 2r. Please note that this is actually the initial altitude. Altitude plus radius is the total distance. So in that energy formula, right? In that energy formula, minus gmm by 2r, this small r is radius plus the altitude. Keep that in mind. Okay. So this will become nothing but minus gmm. 2 plus 1 is 3, 3 2s are 6, so 6 times of r. That is initial energy. Similarly, we can write final energy will be minus gmm divided by 2 times of radius plus the altitude, which is basically 4r. So this will become minus gmm. 4 plus 1 is 5, 5 2s are 10, so 10 times of r. Now comes the difference of the energy. So the difference of the energy is final energy minus initial energy. So final is this, initial is this, where negative gmm by r is common. What is different is 1 by 10 and 1 by 6, which are being subtracted. So minus gmm divided by r, 10 6 are 60, and you'll have 6 minus 10 over here. So minus gmm divided by r multiplied by 60 below. 6 minus 10 is minus 4. Minus minus will cancel, and 4 goes with 60 15 times. So G capital M divided by 15R is my answer for delta E. Is my answer for delta E. Is that right? Also, remember, kinetic energy is always negative of the total energy. So the change in the kinetic energy is also negative of the change in the total energy. So therefore, the change in the kinetic energy will be exactly this, but with a negative sign. So minus gmm by 15R is the difference of the kinetic energy. That's all. Okay. Vimala, you have a very good news which is going to be shared tomorrow. And the timing has been taken into consideration of many students, especially from South, and many kids who have late afternoon or late evening schools, which they leave and they take some time to reach home. So it has been taken into consideration. So there is a very good news for all of you tomorrow. Okay, cool. Let's move now to the final concept, which is of escape velocity. If you are so bored, you want to leave the planet, you move with the escape velocity. The gravitational pull will never be able to pull you back onto the earth because you have so much of energy that you are propelled from the gravitational field so that you never ever return. So your kinetic energy is completely converted into potential energy at when you reach infinity, and the escape velocity formula is root 2 gm by r. For the earth, it is around 11.2 kilometers per second. And if the escape velocity crosses the speed of light, well, nothing actually can cross the speed of light. Even light can't move faster than speed of light. Then that means you cannot escape that planet's gravitational pull. Then that planet becomes a black hole. So if this value somehow becomes equal to speed of light, that's it. The mass or the radius has been designed such that nothing will be able to escape. So it becomes a black hole. All right. So for Earth, it is 11.2 kilometers per second. Let's have a look at some of the questions coming up on your screen. What do we have? To project a body of mass m from the Earth's surface to infinity, the kinetic energy is how much? Okay, let's visualize this. You take this particular mass, you are throwing it. How much kinetic energy you need to take it to infinity? That kinetic energy is half m escape velocity square. As simple as that. Escape velocity is root of 2 times g capital M by radius, and we have to square it, so that root will just vanish. So 2 times gm divided by r will be there. Is that right? Now what do we do next? 2 will cancel, everyone? Yeah, 2 will cancel. What next then? If 2 cancels, okay. So this will become gmm divided by r. But sir, the answers have small g. What do we do? Don't worry. Deliberately put one r square here. So you will have m over here and one r over here. Anyways, the r's will cancel. Why did you do it, sir? Because this guy is nothing but small g. So g into small m into capital R. GMR. That's it. Option number 2 is the appropriate answer. Sometimes you will have to manipulate things. You will find that none of the options are matching, but you don't get scared. Maybe it is in a different form. So you use some other formula. Oh, I know gravitational acceleration is gm by r square. So if I put r square, I'll have to put one extra r on the top. That makes it simplified and matches with the options. Is that right, everyone? Got it? Perfecto. Let's do the next question on your screen. There is an object which is kept at rest at a distance of 3r above the Earth's surface, where r is the Earth's radius. The minimum speed with which it must be projected so that it does not return back to the Earth. Okay, so let me draw that particular planet, and basically about where r is the radius. All right, and this is the mass of the planet, and you have kept something at a distance of 3r. Okay, so this is 3r, and now you are throwing it with some velocity, let's say u. What is the speed so that it does not return to the earth? So when it goes away, finally it reaches infinity, the kinetic energy finally is zero. Potential energy also will be negligible, because infinite distance at that infinity, potential energy gravity wise is zero. Okay, so use conservation of energy principle. That's it. That will help you. So initial kinetic energy plus initial potential energy is final kinetic plus final potential. Final kinetic is 0, final potential is 0. Initial kinetic is half m u square. Potential energy is minus gmm divided by this distance, guys. That is basically 4r from the center of the planet. So you're going to put 4r over here. So therefore, mu square by 2 is gmm by 4r. 2 cancels, cancels. So u square is equal to gm by 2r. Therefore, u is equal to root of gm divided by 2r. Gm divided by 2r, root of it, that is option 1. Perfecto. What a question. So some of you think sometimes derivations are not important, but this problem proves it otherwise. If you knew how escape velocity is derived, the derivation is very much similar. It's based on conservation of energy. So when you're throwing, it has kinetic and potential energy due to the planet. When it reaches far away, the kinetic is 0, potential is 0. So that's it. Conserve the energy, you will get the answer. A lot of people think, sir, how come final energy is 0? Well, when you reach so far away, it has hardly any speed, hardly any energy. And when you are close by, the potential energy is negative. So don't get scared. How will the LHS be equal to RHS? Yes, this is a positive term. This is a negative term. When they add, they become 0. So it's perfectly fine. Nothing wrong about it. Okay. So moving ahead to one more question on your screen. Earth has a mass 8 times and radius 2 times that of a planet. The escape velocity of Earth is this much. The escape velocity of the planet will be how much? Interesting. Escape velocity formula is root 2 gm divided by r. So if I put over here escape velocity, let's say, of Earth upon escape velocity of that planet, it will look something like this. It will be proportional to the mass of the Earth upon mass of the planet, and inversely proportional to the radius of the Earth, and radius of the planet will come over here. For Earth, it is 11.2. For planet, I do not know the value, so I'm just going to leave it as it is. It's mentioned Earth has a mass 8 times of that planet. Earth's mass is 8 times of the planet, so Earth's mass is 8 times of the planet, 8 is to 1. The radius is 2 times of the planet, so radius of the Earth is 2 times of that of the planet. So 8 by 2 is the root 4 over here. So therefore, 11.2 multiplied by root 4 is equal to velocity of the planet. Is that right? Just, oh sorry, root 4 will come down, my bad. Root 4 was on the top. So divided by root 4 is equal to velocity of the planet. So root 4 is nothing but 2. So this will become how much? 5.6 is nothing but velocity of the planet. So that is my second option. Second option. Yeah. Can we use escape velocity formula for the previous question? No, my dear. You cannot use, please do not use escape velocity formula root of 2 gm by r. This is not valid here because it is only when you throw it from the surface. Only when you throw it from the surface. That is why the crux of the problem was the object is at some distance above the earth. So it is not on the surface. So you are not allowed to use this formula. Got it? So those formulas for escape velocity are only valid when you are throwing it from the surface. That's why the derivation becomes important. What will happen if you throw it from inside the earth? What will happen if you throw it from outside the earth? All right. So that's when derivations become important. Now the entire PDF will be obviously shared with you. The link for this particular PDF will be there in the comment section. Do not forget to like this video, share this video, and mention all 5 days done. All the 5 days done. This was a 5-day challenge on the channel, guys. So if you are not live, at least watch it recorded. All the 5 days, 15 chapters, 5 days we have taken 3 subjects. Yeah, physics, chemistry, maths, physics, chemistry, maths. That has made it 15 chapters, which are very, very, very important. So please watch them. Yep. This is tomorrow's most awaited session. Go ahead, subscribe to the channel, like this video, mark your attendance because something really, really big is happening tomorrow. Lots of surprises are there. It will be not just shocking, but also very motivating. Okay. So see you guys. This was your Captain Shreyas. Bye bye. Have a great time.